All right, here's an interesting problem. It gives us a parallelogram with a square in the middle of it and some other information. So as always, let's read the question line by line and pull out the information line by line and mark up our graph or our picture here. So it says in the figure above, ABCD is a parallelogram and EBFD is a square. The area of ABCD is 112. So the area of the parallelogram equals 112. And then it says the area of the square is 64 meters squared. So I usually write it in the center. I know area, but let's just put it over here also for accuracy. Area of the square is 64. And it wants to know what is the length in meters of AE, which is right here. So this is what we're solving for. All right, there's a couple ways to solve it. I'm going to show you the hard way first, then we'll talk about the easy way. So let's work with the information they tell us. The area of the whole thing, let me kind of shade in. So the area of the whole thing is 112. And then if I subtract the area of just the square of 64, that then should give me the area of the two triangles on the side. This is the no calculator section, so I need to do the math in my head. So let's see, 64 and 6 would get me to 70, and then 30 would get me to 100, and then I still have 12 more on top of that, so that's 48. All right, so 112 minus 64 is 48. Okay, so now I've got, I know that's the area of both triangles, right? So let me divide by 2 to get the area of one triangle. So the area then of one triangle is going to be 48 divided by 2, or 24. All right, so now I know the formula for area of a triangle is 1/2 base times height, and I know that that is equal to 24. Now, let's go back. What we didn't pick up originally, let me change colors here, that they told us the area of this square bit is 64. Well, I know the formula for area of a square is s squared, right? So then if I square root each side, then I know the side, or s, is going to be 8. So I know that this is 8 and that is 8. And look at that. Now I can use that for the height of my triangle. So 1/2 base times height of 8 is equal to 24. And then that would be 4b is equal to 24. Divide by 4, b is equal to 6. So the answer here, the length of AE, should be equal to 6. Let me show you an easier way to solve it. Okay, here's our parallelogram. Area of the parallelogram is 112. Area of the square is 64. I'm going to use that because I know that is equal to side squared. So then s is going to be square root of 64, or 8. So I know then that this is 8 and that is 8. And I still, of course, am trying to solve for this bit. Now, if you know the formula for area of a parallelogram, this is super easy to solve. So area of a parallelogram is base times height. And we know that that's going to be 112. So now this is not base times side, and this is where a lot of my students get mixed up, right? So this is the side of the parallelogram, right? So often the SAT will give you the length of the side and the length of the base, and then they'll be like, oh yeah, it's side times base or length times width, but that's wrong. Length times width is for the area of a rectangle. Area of a parallelogram, you have to take base times height, right? We have to take this version. So it's going to be the base, which we don't know, we're solving for, times the height of 8 is equal to 112. Divide out by 8, base is equal to, I got to do it in my head, right? 8 goes into 11 one time with 3 left over, then 8 into 32. 8 times 4 is 32. So B should be 14. Now, a lot of students will jump and say, oh, look, isn't that convenient? That's choice C. But remember, I solved for this whole thing. This whole thing is equal to 14. And they want me to find out what is this small bit. So you can see all I need to do is take 14 minus 8, which should be 6. And so this small bit is 6. That's what they asked for, and that is the right answer, choice A. So what's the takeaway here? The takeaway is know the formula for area of a parallelogram. That's the easiest way to handle it, which again is base times height, not base times length or width. But if you can't figure that out, you can just solve it as we did in the first time of just taking the area of the whole shape, subtracting out the area of the square in between, and then realizing that was the area of the triangles, dividing by 2, and so on and so forth.